So now in this video, I'm primarily focused on talking about parallel resistance. You start learning parallel resistance really quickly when you study electronics, and really parallel circuit, same principles, but we actually get to see LEDs light up to prove the points that we make. So there's formulas out there and stuff. I'm not going to go into those. This is just going to be a demonstration to hopefully make it easier to understand if you find it confusing, which I actually did when I first started learning electronics. So here we have 4 LEDs. Each one of them is protected by a 1 kilo ohm resistor. And so there's probably about 3 milliamps of current going through there. The LED is probably blocking about 2 volts, which will leave 3 volts because it's a 5 volt power supply across the resistors. Since they're 1 kilo ohm resistors, if you have 3 volts across it, you'll have 3 milliamps of current running through it. So everything's not perfect though. There might be some slight differences, but it's going to be really close to 3 milliamps of current going through each of these LEDs. So there's 4 of them here, which means if 3 milliamps of current is flowing through that LED, and that one, and that one, and that one, then the power supply is providing 12 milliamps of current. And so when you study Ohm's law, the current is the resistance divided by the voltage. And so the only way to get 4 times the current is to have 1/4 of the resistance. So right now these LEDs are these resistors are actually acting kind of like a 250 ohm resistor. So it's equivalent. They're still 1 kilo ohm resistors, but as far as the power supply is concerned, they are basically 250, a single 250 ohm resistor in equivalent. So we'll look at that coming up. Now, another thing to notice, the power supply, if we yank that LED, the brightness of those LEDs did not change. We yank that one, the brightness of those 2 LEDs did not change, and that one did not change. So now we have 1/4 of the current flowing that we did before because we yanked those other ones. So now the power supply is providing less current. As far as it knows, because it doesn't know what's down the line, it's just providing power based on how much resistance it is getting. So ultimately there's more resistance now than there was before, even though we have less load as far as the power supply is concerned. And that's mostly what we look at. So now we're going to look at another way to look at this. So again, the LED is wired forward bias. The short lead, the cathode, is going to the negative rail. We'll be adding resistors so that the long lead, the anode, goes towards the positive rail. And so we're going to add this resistor, and ultimately we're going to add all 4 of them. So you saw the LED light up now. That's because we got the resistor. We can be pretty sure that it is about 3 milliamps of current flowing through the LED. Now, we are actually going to add the resistors in parallel, just the resistors. The LED is in series now with 2 parallel resistors. So you can see the LED got, see if I can shade it, that will make it easier. You can see that it's getting quite a bit brighter. It's actually passing twice the current, and the exact brightness is not exactly based on how much current is flowing through it. It seems to get brighter faster at lower levels of current that are increased, but still it does get brighter as you pass more current through it. Now we're going to add a 3rd one, and you're going to see, I'll try shading it again. There we go. Once we make that connection with the 3rd one, it gets brighter again. There we go. And again, the 4th resistor, just to prove it. We already proved the point, but we'll add the 4th one. And I actually blocked the slot that I needed to put that one in. So we'll shuffle it there. That didn't take too long, so we'll just keep it in there and look at adding the 4th one. And you can see it gets brighter when we add the 4th one. So now we are going to use the multimeter to measure the resistance. So these are all 1 kilo ohm resistors. I got them out of the same bag right there. We will take this here and just measure. It's auto ranging meter. All I have to do is set it to one setting, and it's not part of a circuit at all, but there you can see 0.997. That's in kilo ohms there though. You can see the top right there, that's kilo ohms. So it's going to show us the value in kilo ohms. 1 kilo ohm is 1000 ohms. So there we go, we have 1000 ohms. Now we can measure this independently first if we want, and see. Again, electronics is not perfect. These resistors can be expected to be about 1% higher or lower than their rated value, and they're also cheap, so they might be slightly off. But there we can see that was also a 1 kilo ohm resistor. We are connecting it in parallel now. So since they're equal value resistors, that makes the math really easy. I actually missed the row that it needed to go. So if you ever have a, in fact, let's do that right now. I will miswire this, and so now we expect half the resistance. We expect 500 ohms, and if I measure across these two, actually these two way over here, this is actually measuring this one resistor there, right there, because you can see we have the path from there over to there. So we're measuring that one. If we come here, we're only getting that one resistor. So if you have an estimate of what you want and it's way off, check your wiring. So there we go, that was the two independent ones. Now we got them connected in parallel, so make sure you check your connections carefully at all stages. There we go, we got 500 ohms of resistance, slightly less, but we saw that both of them were slightly less than 1 kilo ohm to begin with. And again, we'll measure this one separately just to prove that it's 1 kilo ohm. And again, it's slightly less again, so we're going to have a little bit less than 333 ohms right there. Okay, they are in parallel, I can tell right there. And then you can see slightly less than 333. And again, the fourth one, just to prove the point. So now the reason why I picked 4 here, it's a bit more obnoxious than what I needed. We already proved the point. At 250 ohms, we got this jumper here. We will measure current. And remember, LEDs should be, power supply was off, I just turned it on. They should be limited to 20 milliamps of current. And there you can see, we got 20 milliamps of current with the 4 of them. And we will take this LED here now. That was just with the resistors. And the LED, remember, it's blocking about 2 volts. And probably about 2.2 volts right now. Almost half of the power supply voltage. So now we have about half of the current, as you can see there. Let's yank this out and drop down to 3 resistors. First we'll measure the current. So it's about 15 milliamps now without the LED. And then also, when you look at the LED here, that should be about a multiple of 3 milliamps. So 3 times 3 times 3 is 9. And there you can see it's slightly less than 9 milliamps of current. And we will yank this out and look at it with 2 resistors. So ultimately, what it is doing when you put resistors in parallel is you're adding up the current that they can provide. Even if after you put them in parallel, there is another component in series with it. So now there's 2 resistors with an LED, whether they're independently connected to an LED or if they're in parallel connected to an LED. The LED is dropping a fairly reliable amount of voltage. It does change a little bit based on how much current's flowing through it, but it's pretty reliable. So to make things easy, you can just say this LED is blocking 2 volts. And that means with 1 kilo ohm resistor, we'll get 3 milliamps of current. But we have 2 of them in parallel. They're both passing current as if the other one doesn't exist. And they both recognize the LED though. So they both have 3 volts across them. 1 kilo ohm resistors, they're letting through 3 milliamps of current. And we'll look at that again just with the last one. So this you probably learned before you learn about parallel resistors. 5 milliamps of current through a 1 kilo ohm resistor because it's a 5-volt power supply. And maybe you'll learn about the LED voltage drop before parallel resistance, or maybe not. But there you can see. Now we got 3 milliamps of current because the LED is blocking about 2 volts. And we can prove that too. So in any case, have fun taking these multimeter measurements. You learn a lot about circuits, and just taking these multimeter measurements, it does kind of look intimidating at first, but once you get good at it, it's pretty easy to use a multimeter. So that's the voltage across just the LED, and it's slightly below 2 volts. But again, this is only one resistor here. We will look at that. There you can see we have 3 volts across it, a little bit more. So it's very low current flowing through the LED now. I'll quickly add the 3 other resistors, so there's 4 of them in parallel, and then we'll look at the voltage across the LED and the 4 parallel resistors. So this is going to be, I think it was 15 milliamps before, no, 12. It was about 12 milliamps before. I remember that now. We will look at the voltage across the LED. And there you can see, now we have 2 volts across it. And we go across any of these resistors because they're all connected to the same nodes. There you can see, just slightly less than 3 volts across them. We could go up there and measure too, but it doesn't contact as well. Right there. Or I could go to the jumper there because that's all one node. It's all one conductive area. So, in any case, hopefully you found all that interesting, and the main takeaway though, as I said before, is that when components are parallel, they have the same voltage across them based on where they are in a circuit. So all of these resistors are on the anode side of the LED where they connect, and then the other side where they connect is to the positive side of the power supply. So they have the power supply minus the LED voltage drop, and that is consistent across all of them. Each one of them though is letting a little more current flow, so the LED is blocking a little bit more voltage. That has to be accounted for, but that's a very small change in the grand scheme of things. The main thing is we basically have the same voltage across the resistors no matter how many we put in parallel for the most part. And so since they're equal value, it will be like having, if you have 2 of them, it would be like having half the resistance, 3 of them like 1/3 of the resistance, or 4 of them 1/4 of the resistance. It's a little more complicated math if they're unequal value, but that's something to study, and hopefully just knowing why it's a lower resistance, like this equivalent resistance I should say, will make it easier to understand that math and everything. So hope you liked the video. Thanks for watching. I'll see you in the next one.